So, Ruben built me a new house. So look, check it out. It has, it has, it has it has a roof and everything, walls. I don't know if it has a stove in there and a kitchen and a bedroom and a living room and all that stuff. Can you see it? Where are you, camera? Oh, let me zoom in. So that's my new home. You're welcome to come visit me if you want. But you have to bring a housewarming gift if you come. So. And I take food too, because especially pizza. I like pizza. Okay. Thank you, Ruben. I feel much more or less homeless now. No, just kidding. Okay. We were actually studying. So we were going over my notes for a class that I'm taking from an app called Aztec software. It's an interdisciplinary material, and we're in the math section, and we're don't knock over my house. I will sue you. I have homeowners insurance. Just kidding. Even though you're the one who built it. So now we were learning about the different kinds of shapes. We started out with a triangle, then we did we're doing parallelogram currently, and basically shapes are consisting of four connecting line segments, and they create a closed shape with angles inside of the shape. And for triangles, all three angles add up to 180 degrees. For quadrilaterals, which are polygons or shapes with multiple sides, polygons with 4 sides instead of 3, all the 4 angles add up to 360 degrees. So knowing the sum of the angles, if you're given just one or just one of the angles or two of the angles, sometimes you can find the missing angles, etc. So we learned perimeter is the sum of all the lengths of the sides of the polygon, and the area for triangles is half times the base times the height, and base and height are defined as the two line segments which create a right angle. So half the base times height, and usually you will be given this information in either just written out or in a diagram format. So you're going to have a right angle, then the line segment going up at the right angle is the height. The line segment at the bottom horizontally at the right angle is the base. Okay. And the third side, which you don't really use for area, you just ignore it, is the hypotenuse. So if you were to look for the lengths of the sides, depending on what kind of triangle it is, we learned the different kinds of triangles. If it is a right triangle, you use the Pythagorean theorem, which is a squared, a being one side plus b squared, b being the second side, c equals c squared, c being the hypotenuse or the longest side. And you can find out the lengths of the different sides. If you know like 2 lengths, you can find the third unknown length. Equilateral triangles have all 3 sides and angles. Isosceles triangles have 2 identical sides and opposite identical angles, and the third side and the third angle are different. And scalene triangles are all 3 different lengths and angles. Now, then parallelograms and rectangles, the way you find area is length times width. And same thing for squares. So rectangles, squares, parallelograms, rhombuses, all use just length times width. If the length and the width are the same or different, it doesn't matter. You're just always going to do length times width to get the answer in square units for area. And what else? So rhombus again, base times height. So with squares and rectangles, all interior angles are identical, right? 90-degree angles. With rhombuses and parallelograms, the angles are not all identical. There are two sets of identical angles. So two are the same and the other two are the same. And each set of angles that are adjacent in your polygon add up to 180 in order for all four angles to add up to 360. So if you know one angle, you can find the adjacent angle in all the angles. We did that. Okay. So once again, the Pythagorean theorem is an equation describing the sides of a right triangle by the formula a squared plus b squared equals c squared. And you use this for right triangles in order to find the height, because you're going to need height times base to find area of a triangle. And you divide the product of height times base by 2 to find the area of a triangle. And then for trapezoids, trapezoid has one pair of opposite sides that are, well, two sides are parallel, and two other opposite sides are not parallel. And just as with like rhombus, parallelogram, etc., with strange shapes, because they're not all right angles, you have to yourself physically draw in the height at the right angle that connects at the spot where on the base where you can connect it up to the angle that goes up. So you make a right angle, you draw in a right angle and create a right triangle. So that's for trapezoids and rhombuses and parallelograms, whatnot. So you make a perpendicular line straight down from one angle down to the base. And the area is found for trapezoids by the formula. So in parentheses, base 1 plus base 2. So the lengths of base 1 plus base 2 times half the height. So whatever the height is divided by 2. So we got an example here. So if the base is 6 meters on the top base, so trapezoids have two bases, one on top, one on the bottom. So, and then base 2 is the longer base, is 9 meters. And you're given the distances of the side segments don't really matter, so we ignore those. All we need is base 1, base 2, and the height to find our area, because we're not finding perimeter. And then, so here the height is given as 4 meters. So we plug it into our equation, half times height times base 1 plus base 2 in parentheses. So base 1 plus base 2 is 9 plus 6, which is 15. And the height being 4, we divide that by 2, we get 2. So 2 times 15 is 30 meters squared for the area of our trapezoid. So the only thing you're going to need is height and the two bases. Just like for rectangles and other parallelograms, you just need height times for parallelograms, use base times height. For triangles, half times base times height. Example, parallelogram, height is 10 meters, base is 14. The other sides don't matter, so base 14 times 10 height equals 140 meters squared. So you use the properties of a right triangle, or to find the area.